this problem, we have another truss. Looks like this. And really the only difference in this problem is that we have now a horizontal load acting on the truss as well as a couple vertical loads. The horizontal load is 9 kips and the vertical loads are 5 kips each. So we can look at the overall structure and draw a free body diagram and do a force and moment balance. And we can find these reaction forces. KY is 17 over 5 kips. KX is 9 kips, and B is 33/5 kips. And so we want, in this problem, we're asked to look for the stresses, or the forces in sections, in members A, D, C, D, and CE. That's this one, and this one. So we'll take a cut right here and draw a free body diagram with now these member forces exposed. And we can proceed as we were before and write all these force vectors mathematically in terms of a magnitude and a direction. So this is the unit vector from C to D, so a unit vector in that direction. A unit vector from A to D, which would be just a unit vector in the X direction, and a unit vector from C to E, which would be that. Once we write all those down, we can easily write these in vector notation, and then we can just sum the vectors and set that equal to 0, and that'll give us two equations, two scalar equations, one for X and one for Y. And then we can take the moments. We know we can write the position vectors to C. So the moments about B, we would have RC cross with FCE, RC cross with FCD, which would give us 0. And then we can have RA crossed with FAD and RA crossed with F1. And those would be our moments that we'll have. And if we, then that'll give us a third equation, and then we can solve for these three unknowns here. And it turns out that FCD is 0, FCE is 561 over 40, and FAD is minus 27 over 8 kips. So let's see here, AD, this is in compression up here, and that makes sense. CE down here is in tension, that makes sense. Because we're going to be, this thing is going to want to bend like this. So the upper one should be in compression and the lower ones should be in tension.